Hey everybody. I'm just sending some other social media things out to get people over, hopefully. Okay. Hello. Hi everybody, thanks for coming. Okay. Whenever you guys are ready, go ahead, write some questions if you got them. Or if you just want to listen to people, that's okay, but I would it helps me a lot if questions are always coming. Thanks for everybody that showed up last time, by the way. First time yesterday was really, really successful. Hi Jordan, how's it going? My My phone camera is annoying me today. Keeps flickering a lot. That's okay. Can someone start me off with a question if you don't mind? Anybody? Jordan, maybe? Okay, perfect. Thank you so much. So, can you tell the main difference between data science? Yeah, yeah, it's a good question. Difference between the technologies we use for both data science and machine learning. So, it's a really good question. Even I struggle sometimes when I try to explain this to people because it really depends on who you're talking to. Hi, how's it going? Um, because data science and machine learning, so if you're a data scientist, you likely know machine learning, but you don't necessarily know machine learning. You definitely know stuff like pandas. If you're trying to stay modern, probably Apache Spark slash PySpark, and at least fitting some statistical models. So even if you don't have a super strong statistics background, hi, how's it going? Um, you probably, if you were doing data science in general, you probably at least kind of understand the statistics behind things, and you're at least number crunching from a table point of view, and you may or may not turn those into machine learning models. But so the difference between data science and machine learning, it's kind of tricky because it's machine learning is more so a subset of data science because data science is like kind of all encompassing. But most data scientists, if you're going to ask someone like, hey, are you a data scientist? That means you're kind of asking them, do you know machine learning? So kind of tricky, but the differences between the technologies are if you're just talking about data science without machine learning, it's definitely Spark. You should probably use Spark. Not to say that you can't use Spark involved in machine learning, but you can. There is definitely like pandas you're going to use very heavily. R, you're more likely to use R if you're doing just kind of data analytics. And so really when I mean data science without machine learning, I mean data analytics. So Spark for sure. SQL you would use a lot in both, although you're not going to fit machine learning models using SQL. You're going to, whether you're doing data science or machine learning, you're definitely going to be using SQL to get all of your data. Or if it's not SQL, at least using SQL like syntax to try and get to get the data from wherever it's coming from, whether it's with Spark SQL or however the SQL system is set up. So the differences between the technologies are data science is about, uh, aside from machine learning, it's just analytics. And so machine learning is like, regression, which may or may not count as data science or machine learning, depending on who you're talking about, or what you're talking about. Classification and all of the more modern stuff like image classification, object detection, natural language processing, forecasting models using like LSTM, so modern neural networks, then that's all going to be done with machine learning, which a data scientist may or may not know. keep asking questions about that. If that didn't make sense, please ask some follow-ups because, it's kind of a tricky question. Recently enrolled in World Quant University, online university. Okay, definitely haven't heard of that, but cool. For an applied data science course. Okay, that's cool. If you have time, check the course they offer and share your review about it. Sure. Yeah, okay. I mean, if we're ever at a point in this stream where it's a little bit lower on the amount of viewers and not many people are asking questions, then I can definitely just take a look at that with you. That's totally fine. If not, I'll definitely get back to you later. What is data validation and how do you validate? Yeah, it's kind of a weird thing. And let me just bring it up to you as the definition that we can read together to really diagnose what they're saying. It's a really weird concept that I don't run into that often as a data scientist. It's more from like a business analyst almost point of view if you're going to see it. So data validation restricts the type of data or the values that users enter into a cell is what it comes out from an Excel point of view. It pretty much means, and I'm not just bringing this up for me, I'm just trying to get you a couple different definitions you can read off and explain those. So it's ensuring, this is actually a really good one, ensuring data has undergone data cleansing to ensure that is, they are both correct and useful. So data validation is not about making machine learning models or doing analytics on the type of work. It's making sure that it actually is what you want it to. And this is difficult because definitely take string values, for example. So I'm just going to get rid of this. Like a string is really like any piece of information. And there's a lot of times that you're going to ask for a string and it just doesn't look like you want it to. And as well as even just dates and numbers is you might get in data that, passes the first initial checks, as in like, we're not just going to reject it completely. It still gets past those tests, but we need to make sure that it's validated, as in it looks in the right format, so that we can do stuff like machine learning and analytics and do the whole extract, transform, load, ETL thing, so that we can move the data around and we're sure in the company that it's at this point it's really what we want it to be, so that we're not messing anything up. I hope that made sense. And it's not the role of, it's not too much, I'm not going to say it's not the role, but it's not too much the role of a data scientist or people in these fields. In bigger companies, you're going to have some people that are really devoted to these things. And if you're not talking about it from just a job point of view, there's still a lot of people that, data scientists still might do data validation because, they need to make sure themselves that the data is going to be in the format that they want it to. Okay, I'm going to take a quick drink here in my invisible mug from last time. Must we do mathematical methods for all data science? So are you asking the question, and I'll just answer while I'm asking the question back to you, but are you asking the question, is it necessary to understand the mathematics for all of the machine learning algorithms? Because like while you're doing a project, are you saying, do you have to go through the math and understand the math? Or do you mean while you're doing a project, you have to make sure that you actually show to the person that, you're talking about the project, do you want to show them the math that's involved with that? Or do you just want to show like what it actually does? So if you're talking about whether you need to learn math for all of these to do data science projects, are you saying if you just need like to learn Keras, so the TensorFlow.Keras, say if you're using that which is a very high level library to do many data science and machine learning type work, and so sort of yes, sort of no, you're going to be a lot better at making a good model for sure if you understand the math that's under it, especially if you at least understand. And that's why in my ML course I make a huge emphasis on understanding at least the important fundamentals in linear regression, because if you understand all of that stuff, you're going to be a lot better at even just making these different neural networks, because unless you've just done like 1,000 different models and you have a really good feel for it without understanding any of the math, it's really hard to actually get a feel for it unless you know what's going on underneath. And at least if you understand regression, then you can transfer that knowledge to something like a neural network very easily, because you just kind of play around with the different variables. You go, oh, I can do feature engineering like this. I can actually do this to the variable, and that might help. Or what would really help is if you understand, say, at least kind of how the parameters are being tuned, because if you don't, if you don't even understand, like, you're taking derivatives of some loss function, and that's just tuning these parameter values, you're going to get really lost when you make these models. If you're just looking at the model itself, like, what is this thing? Well, it's just a bunch of parameters and it's just a bunch of calculations, and that's not really going to make much sense. But yes, you can get by for sure if you don't actually know all of the math underneath. I would definitely recommend understanding like regression and that type of thing. Even logistic regression, if you can, would really help, because that's your first step to nonlinear regression, like neural networks. But do you have to understand all of the math? No, but I think it's a really good use of your time if you can. And the trick is just to make sure you do it in order and not to jump into math in the middle. Like, if you say you've been using neural networks for a while and you don't understand the math, and then you jump right into the math of neural networks, you're going to get pretty scared. But as long as you take it step by step, like starting with, simple linear regression, multiple linear regression, maybe logistic regression, and taking derivatives and getting parameter values, all this stuff is going to start making a lot more sense, and it will transfer to your models for sure. What tool are you using for live stream? Oh, so I'm using OBS. So you can actually see at the bottom here, if I go out, this is OBS, and it's just like an open source or free way of streaming this material. And I have a chroma key so that, behind me is actually like a green background. So that's why I'm appearing on the screen or whatever. Okay. Hopefully that made sense. So can someone else please ask some questions? I would really appreciate that if you don't mind. Really anything, just even if it's just about like motivation, or, not necessarily something super technical, although I can answer a little bit of technical questions. Advice for certifications, just whether you're feeling, nervous, like, why are you here? Why are you listening to me? I'm really curious as to why you would come in and just listen to me talk and answer questions, because you probably have some questions that you want to ask and you're just a little bit nervous, and that's totally okay. But I would appreciate it if tried and got out of your comfort zone, asked some questions. Okay. Yeah, that's a good question. Is data structures necessary for data science? So, a couple different points of view. I'm just going to take a quick drink if you don't mind. I love invisible mugs. So data structures for understanding, like if you're saying like, do I need to take a data structures and algorithms course, or study this in university, whatever? Do I need to understand like a hash map, an array, a dictionary, which is really just a hash map? All of these various things like heap, tree, graph. Yes and no. Like, so data science is programming, okay? 100%, nearly all of your work will be doing coding. And so everything under the scenes, or everything under the hood, all of these high level objects that you're using are classes. All of these classes are made up of data structures. And so understanding how they implemented those data structures is definitely beneficial just for a coding point of view, as well as, like, data science is coding. Like, I separate it from the high level data science objects like neural networks, like how Kira's would make a neural network. Of course, there's all this stuff under the hood. But aside from all that coding, there's going to be a lot of times when you're still doing data science, as in you're a data scientist, you're on the job, but you're not writing code that's like just making a neural network. You're going to be using lists, filling stuff up with lists, knowing when to use a dictionary, and it's very helpful to understand why you would want to use an array versus a dictionary. why is it faster that you can look up a value by a dictionary rather than an array? If you don't learn data structures and algorithms, you're going to be writing code that is slow and just, kind of clunky and not the best. So it'll really help both making clean code, making fast code, and fast is very important in data science. Although we use Python, which isn't the most fast programming language, there's a bunch of ways that we make it faster. And we still really care about it, especially if you're doing something like computer vision. You need this stuff to be really fast. And if you are on the job, your boss is not going to be happy if they find out that, okay, you're really good at the data science stuff, but they're like, why don't you know how to use a dictionary? Like, clearly that you're just doing some linear search when you should have had an O of 1 or a constant time here. So that stuff, data structures and algorithms, will really help, including, I haven't really talked to graphs from don't picture like an XY axis, picture like nodes and basically lines, edges, and vertices. So it's just a connection of a bunch of things. Say, airports is the most common example. Airports airports are vertices, and pathways between them are edges. That is huge. And actually, if you heard about graph neural networks in the last couple of years, there's been a ton of research on that. So if you want to stay modern, you really have to learn that piece of it as well. And yeah, just learning data structures and algorithms will really help, as well as a final piece I'll go on about, which is if you want to get a job in like a big tech company, so like either FANG level or, the ones that are similar to that, a lot of them still do kind of treat you as a software engineer at heart, because you are doing software. And so you may have to pass, a crazy interview where you need to use, I'll throw out some terms like dynamic programming or depth first search or something like that, which I don't either practice every single day, but doing it once will really help you out. And if you are trying to get that level job, you still need that, even if it's a data science job. Okay. Before modeling data, what are the basic steps? So by modeling data, I assume you mean, making a statistical model that fits the data. So like, say, a linear regression is the easiest thing to do. So before modeling it, well, although people don't often say it, I talked earlier about data validation. And so that's a first step, is making sure that you have data that makes sense. And makes sense just means like, are there a bunch of outliers here? That may or may not be called data validation. That might be called cleaning, but it's up to whoever said it. Make sure that however the data came in, and it's picture a bunch of rows and columns, where your columns are features or different parts of the data, and rows are different observations. So you need to make sure that those observations actually make sense, just from a point of view of staring at it being like, why is there a B in this string? And I'm saying that because like I've done this all the time on the job, where, someone tells you, hey, go get this data from this SQL table, and you go take a look, and it makes sense to you. You do a bunch of work on it, and then you show them results later, and they're like, oh, but why is there letters here? Like, what does this represent? And you're like, I don't know, I thought it was good. So the first step is making sure, if you are in the job, that all of your data makes sense. And then after that, to model the data, well, definitely you would need to look at, say, correlations between them. You want to know if there's a lot of relationship between your features, because if there's, which we usually call collinearity, if there is a lot of that, then you might need to do some feature engineering, or even just drop out some variables because they're going to be redundant. And that actually makes your model worse rather than better. Kind of talks about the conversation of overfitting and underfitting, which I could definitely explain if someone wanted me to. So yeah, make sure that your data isn't too related to each other if you're trying to model it. You need to do a lot of encoding. So, data comes in as, like I'm saying, generally data is stuff. So you need to turn that stuff into features, which may or may not be already done. If you're in a company, maybe it's already set up like that. Even if it is, there's probably a lot of work that you could do to make it better. So that would be, say, changing different variables into categorical variables, or like one-hot vectors, which just means like which actual indicator is it. So which, are you class A, B, or C? That would help. Maybe standardization / normalization, that conversation of, you might need to standardize it, which just means subtract all of them by the mean, divide by the standard deviation, or divide by like the max value, just some sort of thing to get the values between, say, -3 and 3 or so, and that would help prepare your data so that you could feed it into like a neural network or something like that. It just happens to help a lot. Again, if you have follow-up questions on that, please shoot, and I'll get back to it when the time is there. But actually, just a quick follow-up on that, after your data is ready there, you would also, if you're doing machine learning, use NumPy to change it into the shape so that you had proper inputs and outputs to make a model. Okay. You want to become a data scientist in the future? Good. I finished the basics of Python and I enrolled in the IBM Data Science course. Good. After finishing this, can I enter an entry-level job in data science or to learn more? Really good question. Is IBM Data Science job ready? Because they tell you that if you go to the front page, it says you are job ready after you get an IBM Data Science certificate. Um, I'm going to hurt your feelings and say no, probably not. I definitely think that it's an amazing first step. I definitely think that that certificate is helpful towards getting a job, not just in your knowledge, but from a LinkedIn algorithm point of view, looking at you, it's better. Uh, do I think you're really ready for a data science job? You're probably ready for like a data analytics job. Like you could get something like just basic SQL and maybe a little bit of Python or R programming. But for a real data science job, you're probably going to need to step more into the machine learning area, especially moving into the future. It's going to be a lot more focused on neural networks. So I wouldn't say no. I'm not going to say no, you can't get a job. But in terms of probability speaking, I wouldn't give you a huge probability after you do the IBM Data Science to get a good job in data science. It's a really good first step, and I absolutely recommend it. But then I would probably recommend doing other stuff like the machine learning certification and other stuff that I have. I have lots of videos on the certification, so I would check out what I have to say for that. Okay. Deep learning does give better results in natural language processing. My question is why people slash schools slash boot camps teach scikit-learn instead of TensorFlow. Is that true? So I didn't know that that they do scikit-learn for natural language processing. I know there's a lot of other libraries that they do for NLP that I don't really use all the time. Um, so you're right. Scikit-learn doesn't really use deep learning too much. It's more so statistics stuff like linear, logistic regression, that type of thing. I'm not sure if they do any deep learning based stuff. They do some clustering. But anyways, to answer your question, why wouldn't we, instead of just looking particular in scikit-learn, talking about deep learning and natural language processing, uh, yes, I mean, I don't know the answer as to why they would do that. Probably just because from a theory point of view, a lot of people would want to learn like the basic stuff first, even if it's not theory as in like drawing out the math. Theory is in like building up to today's work, which is absolutely, you should be using embeddings in deep learning. Transformer models is, and attention is where everything is. Attention's on attention today, and for the people that aren't watching or that are watching that don't know what an attention in transformer model is, I'm not going to explain the complexity, not that I really could, but that's where natural language processing is. So if you want to learn that, there is a certification in NLP for deep learning that I would recommend that does go that route. And in the deep learning normal specialization, they do have a module on that that definitely gears way towards deep learning. So yeah, that would be my recommendation for sure. One book that you will recommend to any beginner deep learning enthusiast. So definitely the Really hands-on machine learning with what is it called? Keras and scikit-learn, Keras and TensorFlow right now. You'll know what I'm saying. It has a lot of reviews, very popular. It's great to get moving, especially if you're trying to not care too much about the mathematics, especially in deep learning. There's a lot of math there, and it gets pretty crazy, to be honest. Like there's a lot of math, a lot of linear algebra, calculus, statistics, probability if you're going to look at deep learning. And so, of course, I would recommend the Deep Learning book by Joshua Bengio, the the great people. And it's a fantastic book that I definitely haven't read all the way through. I think it would take years to read all the way through, unless you're already a professor. I'm going to recommend it because if you want to learn it well and you're a beginner, then that's what you should do. Nonetheless, to be quite frank, you would probably open the book as soon as it got to the math, you'd be like, "Yikes!" And it's possible to understand it without any other material, but it's pretty terrifying. So I would be hesitant. I would definitely recommend the O'Reilly hands-on machine learning or hands-on with TensorFlow book. They actually have a version 2 of that now. I had the first one and I never got the second one, but I'm sure it's very, very good. And yeah, I would recommend that for deep learning 100%. Okay, so that's the bottom. Guys, I would appreciate it if you keep moving on the questions. Sorry to be rude, but I'm sure there's a lot, so keep it going. Mhm. You're very welcome. Does doing count vectorize? Oh, that's getting pretty specific, and I might not be able to answer. Count vectorization, and I don't know what that word was. TF? DF? Um, does that take care of the data? Is this a Spark thing? I forget. It might be a PySpark thing. Does that take care of the data standardization, or should be done manually before passing the data in? I approached what you're doing once, and I remember looking at that, and I had the exact same question that you had. I don't quite remember. Sorry about that. That'll be covered in the documentation though, so I would just read through, and if not, just kind of apply it on examples, and you'll see exactly what it is doing. Okay. Anyone else? Any other questions? Come on, guys. I know there's a lot of stuff that you want to know, so there we go. For object detection in particular, what is the state of the art in deep learning architecture right now? Uh, oh boy. So the state of the art, I wouldn't be able to keep up with. I definitely looked at object detection about a year ago, and I was looking at the various models, and they're based off. I think they're probably going to be moving to the transformer attention models as well. Um, I'm very glad. Thank you. I appreciate that. So in object detection, is state of the art. I mean, let's honestly look at it together for a brief moment. I'm curious what people have to say. It's all for the last 10 years been based off of convolutional neural networks. And basically they turn that, there's a lot of papers, and actually I read a really nice Medium article that said like the best papers to read if you're trying to learn object detection, and it kind of shows how they go from the basics of just like well before even convolutional neural networks, but then after that how they would kind of linearly search the thing, and that would be very, very slow, and now it's really a parallel. I think the state of the art, to answer the question without looking it up, is probably like YOLO v4, or there's the other one that I forgot the name of that's kind of the competitor to the YOLOs. The problem with object detection right now, just to go on a bit of an anecdote or a rant actually, is that a lot of the applications of object detection are becoming a huge problem. So, a morally problem. So, it is kind of dark and scary that people are using these applications from AI researchers to turn this into like military applications. And so, a lot of people don't like that, understandably. And the people that are doing the state of the art in object detection straight up leave and stop doing work because they don't want the results to be shown. But to answer the question, I bet it's YOLO V3 or V4, whichever it's on right now, which stands for you only look once. And the point is that you only look once. You basically just kind of shoot a weird convolutional neural network, and that's going to give out all the answers for detecting the boxes. How to improve object detection performance? I don't think I'm quite in that space to be able to answer that question. I mean, it's the same type of deep learning stuff. So it's still training a model, so test and validation, that kind of sets. Um, and it's still training a convolutional neural network pretty much. So all of the same stuff that applies to training convolutional neural networks is definitely going to apply. So if we take the problem and translate it into just like a classification problem, or basically trying to figure out what an object is, well, there's a lot of different weird things that you can do to make that better, such as 100% data augmentation is the term, to basically mix around what the data looks like, and that's going to color it differently, zoom in on it, and it makes artificial data to train better. And so I would assume that that's applied in object detection as well. In fact, so much so that they even use games like Grand Theft Auto to, that makes new data all the time. It's just constantly generating it, and that's going to train like kind of self-driving cars almost. So very, very cool stuff. I would assume all that same kind of base machine learning stuff applies, and specific to computer vision, definitely data augmentation, even playing around with what are a class. So like you could play around with, if you're trying to detect in a picture like 5 different classes, you could instead predict like, or try to find 10 different classes and try to find the differences, like look at your confusion matrix and be like, why is it doing this? And maybe make more classes or less classes depending on what makes sense. So hopefully that answered the question a little bit. Do you think ML will code better than humans? So like, do I think machine learning will code better than human? So do you mean like GitHub's Copilot, how machine learning is coding? I'll assume that's your question, and if it's not, then please change, or not change, but clarify. Machine learning probably will code better than humans. It probably already does. Sorry, I'm just looking at the chat, so I'm getting kind of distracted. Machine learning kind of already does code better than humans, as in it is a lot faster at doing, specific things. Like if I wanted to just make a graph, it could do that. If I wanted to make a neural network, GitHub's Copilot could do that. And it can do that because it is supervised learning, which just means that, we are training off of people's existent code. It didn't figure out how to code by itself, which would be a reinforcement learning thing. I bet you they're looking at that in the future. But if you saw GitHub's Copilot thing, like it can code pretty well. And do I think it'll be better than humans in terms of being able to construct like entire systems that all link up perfectly together and there's no bugs with all of the code? That'll be tough. Like it's really easy to make just like a class that does something, but then interacting that with 2, 3, or 4, especially if you're talking about something like AI making like a video game. These things are so freaking complicated, especially if it's an online multiplayer game or anything that's kind of network connectivity heavy, is going to be very difficult for a machine to figure out. But you know what? Honestly, I bet that that's what we're pushing towards. The more code that we write that isn't related to machine learning, or not related to machine learning, I mean, that isn't already being trained on GitHub's model or whoever else is doing this, the more that's being produced, and it's exponential. So the more that we do, that's going to make the models better and better. And companies like DeepMind are looking at, reinforcement learning methods. I would be shocked if they're not, or someone else is not, heavily trying to make code just, by itself, figure out how to code better and better. So I bet you it does. Yeah. Okay, I'm at the bottom. Could you guys ask some more questions, please, if you don't mind? Just anything, motivation, technical questions, thoughts about the future, specific advice for you. Like, even if it's just very specific to you, not that I want to know about your whole life, but, um, you know, ask information specific to you because you're here to learn something. So go ahead. If you're ever nervous about anything, just let me know why you're nervous about this, and I could probably assure you that there's really no reason to be. How long does it take you to feel that you feel okay? No, I read that wrong. How long does it take to you that you feel okay? Now I finished all the stuff, and now I'm a data scientist. I believe what you're asking is that basically, how do I say that I'm a data scientist? How can I claim that I am? Or how do I feel like I'm ready for a data scientist job? What do I have to do to be ready for that? So, agreed, it's a bit of a difficult thing to answer because I've said this before and I said it last time that a lot of these terms are self-declared. For example, I have in my LinkedIn profile data scientist. Of course, I wouldn't say I'm lying about that. I am a data scientist, but who said that I was? Well, actually, yes, some companies did. But even if you didn't, even if I wasn't hired as a data scientist, can you consider yourself one? I mean, you can. There's no time that you can't. Um, and also, no one knows everything. So, like, I don't try to pretend here and say that, I could answer every single question about data science because absolutely not. Like, even top AI researchers would only be state of the art in one thing. So, when do I consider myself or yourself, a data scientist or at least ready for a data science job? Well, you should probably know machine learning before considering yourself a data scientist. Doing stuff like the IBM Data Science certificate is a huge step. And even just the analytics stuff, Google Analytics certificate. I believe I put some in the description of this live if you happen to see it. Some of those certifications would definitely help. And would you consider yourself a data science scientist after doing them? Honestly, it's up to you. But until you feel really comfortable, I wouldn't feel comfortable until I know machine learning well enough that I can at least think about how to solve any problem. If you were to go for it, ask any question about how I could try and solve what kind of model I would use to solve a particular problem, I would be shocked if I wouldn't have a decent idea. And so that's really the power of machine learning is that you don't need to know everything, and yet at the same time, you are able to do everything. So it's different than, a programmer, which, of course, you still learn the fundamentals. You learn data structures and algorithms, and you're able to solve most programming type tasks, even though you don't know all the frameworks or all of that stuff. But for machine learning in particular, you really are, once you understand that a model is a formulation of parameters and an input, it is describing a, you know, statistical distribution. If you're modeling like a multinomial, or I'm going to get into, not trying to get into particular terms here, but the point is you're assuming there's some particular distribution here. You're trying to find it, and then you are measuring the loss of your predictions on your actuals. And then you are using calculus or, gradient descent to update your parameter values, and you know what model makes sense depending on the type of problem. Okay, so all of them work exactly the same way, at least supervised learning. Everything works the same way. Once you get past that step of, you really understand it's just some loss function that makes sense for the model to calculate your error, you have some model that makes sense for the problem, whether it's just a neural network, a linear regression, one of the other ones that are getting a little bit less popular, like random forests. And, there's a bunch of them that are, I'm not going to say random forests aren't popular. It's great to learn, but I would stick with just deep learning if you can. So once you understand what's under the hood, it's kind of like a light bulb that's like, oh, I can solve that problem this way. And what would really help with that is also taking the deep learning specialization. That way, and I have videos that talk about how important these are. I recommend watching that and why I'm saying this. But stuff like taking the deep learning specialization, you'll really open up and be able to understand that it's like, these different pieces of the world, I can solve that with this model. I can solve that with this model. You know in your head immediately, oh, this is forecasting model. I'm trying to predict the future. I should use something that takes into account a time series, like an LSTM model. Or and even understanding that you don't necessarily have to do that. Like it's just a formulation of inputs matching those to outputs via model. And after you understand that, you're good to go. Okay, sorry I ranted on about that one, but let me carry on here. So the answer to that question is basically once you feel comfortable that you have an idea of how to solve most problems. You don't need to be an expert in computer vision or natural language processing. In fact, it helps to be specialized in one of those things and not that good at the others. But I think it would be very helpful if you want to consider yourself a data scientist. You should be aware of the different ecosystem, and also you should know Spark. I would learn Spark so that you're able to handle big data. Definitely understand SQL. Definitely understand most of the machine learning models from a vague point of view, like you know what an LSTM is a little bit, you know what a convolutional neural network is, you know what a base neural network is, you know linear regression, logistic regression really, really well. And maybe some probability and statistics doesn't hurt. Okay, so when do you feel comfortable? Well, it's up to you, but I would say you feel comfortable when you're able to answer different problems with, you just think about what the solution is. How to get started with Kaggle. Personally, I feel like no, you're not. No, sorry, I'm not being rude. I disagree. I don't think you're disqualified for Kaggle, and I don't know much about you. Personally, you feel like you're underqualified, but how should you overcome the mental block? It would be helpful if someday you could make a guide on it. Okay, well, getting started with Kaggle. I mean, I do have it's not the title. I don't have to say get started with Kaggle, but I do have submitting to Kaggle on, say, the Titanic dataset, which is probably the most canonical, most famous. You are 100% ready for Kaggle, and you're not ready to win. God, you're not even going to get close. You're not even going to be in the top like 80%, but that doesn't matter. You're ready to start submitting to it because as you just step onto it and then they're asking you to solve a problem given some data. Even if you know absolutely nothing about machine learning, you're still ready because that gives you the ability to say, oh, what type of problem am I trying to solve? Well, with Titanic, they're trying to model survival rates. Okay, so you're trying to say, really, what is the probability of someone surviving given they have this data? Well, pretend that I know nothing about what this is. What would I do? Well, okay, I'm trying to say whether someone is surviving or not. I might Google something about how to measure like a binary variable. That's really what that is. How machine learning model for binary variable. That's not an amazing Google search, and it's not the exact term, but you'd probably come up with something called logistic regression or a couple other blogs. And after you look at one of them, and even Titanic, even you might even look at a particular solution to that and then understand what they did to solve that particular problem. Or even better, you understand how they solved a different problem and how to translate that into your own. So you're ready for Kaggle. You are not ready to win on Kaggle or do really good at all. And you just need to start if that's what you want to do, like make sure that's actually what you want to do and not just everybody said like, oh, Kaggle is the place for data science, go to Kaggle. It's great. I'm not going to mock it, but it's one platform that isn't necessarily the right thing to do. But I do recommend it. I would encourage. It's a good way to encourage people to learn new things. It's a really good way to get thrown into an ecosystem of, man, I have no idea what I'm doing, but I can figure out one thing at a time. It's like, okay, I need to figure out this. I need to figure out this. I jump into a different problem. It's doing some sort of forecasting. It's trying to predict the future. You Google time series forecasting models, and there's a bunch of them. Figure out which one is good for you, good for that problem, and then see what they did, and then you'll understand it. So I hope that clears it up. If you want to say, and guys, make sure that you have another question after this one, so that I can jump on it after. How to get started with Kaggle, in particular, how to overcome the mental block. I hope that I helped you overcome the mental block. That was my goal, but I'm not you. And so if I was you, how would you overcome the mental block? Well, you need to not be scared of being terrible. You need to not be concerned with going in and getting a terrible percentage compared to everybody else. Or you need to be okay with going in and then exactly following someone else's blog because you don't know what to do. And if you want to try, if you have no idea about machine learning and you want to just power through and try and figure it out without looking up any blogs, going to be pretty tough, honestly, unless you have a decent idea of at least how a neural network works. It's going to be kind of hard to make various models. But to overcome the mental block, you kind of just realize that it's okay to suck at it and go ahead, suck at it, get terrible grades in Kaggle, and then keep submitting, keep learning, keep learning. And that's what I said. It relates back to what I just said, which is I feel like I'm a data scientist after I feel like I can solve many different problems and not necessarily do really well on them, get an accurate solution. I doubt I could do that for many problems, but at least have an idea of a way of solving that. And so that's what you would really gather by looking at various Kaggle problems. It's very hands-on, and that means if you don't know what you're doing at first, you won't be able to be hands-on, but you can read about what other people are doing. So you're fine. Just to be, a little sympathetic with you. Firstly, thank you very much for asking the question. Absolutely, really appreciate it. Secondly, overcoming mental blocks is very important, and it pretty much always just goes back to I'll answer this question the same way every time, and so that everyone hears it when they drop in and out, is to enjoy something or to do something, you have to enjoy it. And if you hate going onto Kaggle and having to look at everyone's solution, then don't do it. If that's something that you enjoy, then absolutely go for it. The best way to learn is to find a way that you like it. And I will say over and over again, I'm sorry for the people that have heard it 50 times, is that make sure that you're doing stuff publicly. Kaggle, if you want, is public, and that's great. Posting on Twitter, YouTube, making tutorials, whatever. Self-taught learning, you need to make sure that you understand the material. And another reason to post publicly is because you need to understand what you're saying to be able to explain it to somebody, rather than just reading a book passively. I'm understanding like, oh yeah, okay, I get what they did here, and then you move to the next page. Well, if you were to instead read that page, try to implement into a Jupyter notebook, and share that with everybody, I'm pretty sure that you wouldn't stop until you were right. You might give up, which I hope that you don't, but you would know that you don't understand it until you make it all the way, and you would implement it yourself, which is really great. Okay. Hi, Greg. Did you ever have to learn? That's funny. Have to learn VBA, and if so, do you have any tips? Um, so I am going to ask you about this. So please respond to me here if you're okay with that. Um, why do you have to learn VBA? Because it's very old school. For those that don't know, VBA stands for Visual Basics for Applications. It's basically what's running Excel. Is the coding language behind Excel, and um, so it's able to automate a lot of these things that you wouldn't just type in the Excel cells. And why would you need to learn that? I'm not quite certain. But if you do for some reason have to learn that, like sorry to be rude, like gun to your head, you have to learn VBA. My tips are the blogs are very good. Yes, I've learned a little bit of VBA. No, I definitely wouldn't be good at it right now. There's a lot of blogs on that, just kind of whatever you're trying to do at the time, just look it up. There's a lot of material out there. So I would definitely recommend just, jumping into whatever you're trying to do and then looking up blogs as you go. It's tricky because it's not really something that I would recommend like, learning. Like I would recommend learning Python as in screw all the applications for now, just get good at coding. And for VBA, I'm not sure if that's the right thing to do, but if you really have to, then yeah, I would just kind of not learn it. I would go ahead and whatever you're trying to do, look up kind of ad hoc is the term, like just out of the blue, I need to do this, look it up. Um, you're very, very welcome. do my first submission this weekend via TikTok. Yeah, whatever it is. I- if you were interested in computer vision, do the MNIST handwritten digits dataset. If you're interested in more of like getting a standard data science machine learning job, I would think about doing Titanic from a couple different ways. I forget which way my video did on Titanic. I believe I just showed how to do it with scikit-learn's. Yeah, I showed scikit-learn's logistic regression, which is really good. But there's so many different ways to do this, like via neural networks, random forests, uh, so many different models that could work. So go ahead, yeah, you'll be fine. Trust me. uh, love from India. Yes, thank you. Is it? Isn't it like one in the morning, 2 in the morning in India right now? Like, what are you doing watching me in the middle of the night? uh, could suggest how to start with Spark and Spark SQL after completing the Python and basics of machine learning. Well, I have a video. I'm not sure if you've seen it. I have a really, really nice video on doing Spark SQL. It's just like 20 minutes, get the basics, you understand why you're doing it, and not just kind of like it gives you all the different functions and like, oh, it's really just SQL, but in Python, and it's doing it in a kind of big data way, which is very parallel, using a cluster of machines to work in parallel that you don't even have to see. You don't have to worry about any of that. But yeah, I have a video on that for sure. And if you ask later as a comment, you could I could show you a certification. I believe I have a certification somewhere as a link, but yeah, let me know if that video isn't good enough. I would definitely recommend doing that. And also, after completing the Python and basics of machine learning, yeah, so that's a good time to learn Spark for sure. You could learn it before machine learning or after. After is probably a lot more common. And yeah, I would watch that video. Okay, great. Awesome. Uh, yes, 1 a.m. Yeah, yeah, it is, eh? Go to bed. What do you think about C sharp? Just kidding. I'm actually very, very happy that you're watching. I really appreciate it. I'm just kidding. So what do you think about C sharp? Um, well, so I'm not gonna say no, I knew C sharp decently well. You know, I actually read, I think it's called the Yellow Book of C sharp or something like that. I'm forgetting exactly what it's called. Really good book. Um, so C sharp, if you're talking about a from a machine learning point of view, sorry, Fade. Oh, I did miss your question. Thank you. Thank you for reminding me there. I'll catch that one after. Um, So C sharp from a machine learning and data science point of view, you know, of course, like it has its stuff. I remember when I was learning C sharp is actually the exact same time I was in parallel learning machine learning, and I saw there was a lot of stuff like the VB uh, machine learning stuff from Microsoft, and it's there. It exists. I'm not sure how well they're supporting it. Probably decently well because they want to keep the .NET stuff alive. C sharp is fine. You know, I think if you look at a graph right now, it's probably decreasing, but I wouldn't be too worried about that. It doesn't really, in my opinion, doesn't really do anything that, you know, another programming language can't. And obviously, I'm going to get 10 haters saying how that's not true. But for the most part, I mean, I would just learn Java over it, or Scala. Um, if you're learning to program, it's there's a nice book in it and it's fine. I don't really love it though. The programming language itself, C sharp, is tolerable, but I wouldn't totally recommend it for machine learning. But it's okay. And yes, thank you. I missed that one. I will catch that. So in the ML, you're in the ML path, but I don't want to be on the product customer side. So making, right. Okay. You don't want to do stuff like a self-driving car or like a, yeah, that makes sense. So I see myself work better in the intersection of machine learning and software. Well, I mean, hate to break it to you, that's everything. Intersection of machine learning and software engineering. Machine learning is software engineering. You're 100% writing software code. I think what if you mean by that, you're more so working on like data pipelines for machine learning. So this is tricky, and I've only gathered this information from doing a bunch of interviews. I haven't had a job in everything, but I've had an interview in a lot of different things. And so there is absolutely a lot of software where basically they would describe it as a machine learning role, except you get in there and it's like, no, you're not making a TensorFlow model. You're not running a regression. You're feeding people the data and preparing that for machine learning. So if you mean that kind of piece of it, which is it's more of a software mixed with machine learning side, then yeah, that's totally fine. Um, so the question, and I guess I missed a couple, I think. Um, so what's my suggested path of action or course of action? If you want to do that, it's a lot of work. So it's to get that type of job is totally okay. It's not that much more difficult. You would kind of need to know the basics of machine learning, not be you don't need to be amazing at getting making machine learning models to get this kind of pipeline-ish job. By the way, when I say pipeline, it just means moving data, changing it around so that it gets in the right format, validation, cleaning, all that point of view. But from something more like Scala, Spark, or maybe even Java or something like that. Okay, so to get that type of a job, it's not that hard. Like I've gotten some interviews for that, even some offers that I didn't want to take because I do want to be on the product customer side, but I totally get if you don't. And my course of action would be learn a fair amount about machine learning, definitely understand like, test validation sets, neural networks would help. But then after you understand that and you're able to answer some basic questions about that, more so focus a lot on software itself. So data structures and algorithms, you're going to get those types of questions a lot in those interviews. Just hammering out the LEET code problems. That's going to come up a lot. SQL still is something that I would learn a lot. And I actually came across, which I mentioned at the end, and if, for those of you watching that haven't seen it, I recommend my machine learning video I recently put out, not for my course, but for the certifications guide. I recommend watching that because at the end I talk about what I call a bonus, which bonus, it's really helpful, is the IBM, I forget what it's called. It's basically full stack cloud web developer, a bunch of terms in there. It really is the mix of all of the different tools over there. That's not about making models, but kind of how it's all going to link up in the end. Kind of related to Flask and Django and that type of thing. Okay, so hopefully that makes sense. Let me see what I missed here. So yeah, okay, I did skip over some things for sure. Sorry about that. How long does it take to, like months or years of training? I want your experience and how long it takes to learn a new skill. Well, you can learn a new skill overnight. I mean, how well do you learn it is up to how much time you put into it and how much you apply it. But you can read about 10 pages about neural networks and then apply it tomorrow. Um, to answer the question of months or years of training, I totally understand why that would come up a lot. You want to know how long it takes to actually get this stuff done. Well, to get a data science job, it's probably over a year of working really hard. You still might be able to get something basic in analytics, even if you're working free, then that's totally fine. Like just getting some experience there. To get a paid data science job, it would take a while. Like it's hard to say because it even took me a while, like maybe even a year, to get good at data science, and that's after I knew linear algebra, calculus, like I've taken Calc 1, Calc 2, Calc 3, Linealg 1, Linealg 2, statistics, probability. That's all 2 years, okay? And that's also computer science courses in there as well. So that's 2 years, and that's before I even tried to do data science. And so it's hard for me to say, like, I never reached a point where I was like, I know nothing. I want to learn data science, which a lot of you are in. You're in that space where it's like I'm starting from scratch. I want to learn data science, and so to do that, I would definitely anticipate over a year of time. Um, I wouldn't focus too much about how long it takes, though. It's about taking it step by step and learning it, realizing you can learn a new skill overnight if you want to. Yes, okay. Yeah, okay, I realized I realized how much I skipped and how much I moved around here. You're very welcome. Yes, best master's university for data science in USA, 50 million question marks. Yeah, so I answered this question yesterday. At least I talked about most of them. And probably the best one? I don't know. MIT, Stanford, those types of universities. I honestly can answer the question as well as you can, not to say I don't know more. I just mean like it's gonna be pretty up to you. What I do want to focus on here in my answer is that it's 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 very tough not to think about what's the best, like what's the best. Think about what's good. And there's a lot of them over there that are good. But good isn't just about, what it says on paper or what other people have to say. Good is about I'm watching this or sorry, I just said that because I was reading. Um, I'm applying to this master's degree and I want to know, I want to learn something. I want to get an experience with a professor. A lot of people don't put that strain on that, where it's a lot more about, if you're doing masters, you are gearing your focus towards something in particular, not just getting a certificate so that you can get a machine learning job. It has to be in something particular. You're getting a master's, yes, in data science, but you're going to take a particular route. So make sure that no matter what you do, if you go to some master's university in data science, make sure that you look at the material very carefully about what you're going to take. You ask people about that, and then also combine that with how good the university is itself. And I'm not going to pretend that I don't care about, elite being elite. Like, not to say my university is the best. University of Waterloo is very good, and I'd be kind of surprised if it wasn't the same opinion in many places for data science in particular, as well as many other things. So I do care about being elite, but I do think there's a lot less. Uh, like it's not just about being better than people. It's not just about getting a certificate that most people think are good. Make sure that you're looking at what it is. Even like I think you might underestimate the amount of time you're going to be spending talking to one or two people, like at the master's degree. Okay, so your professor or the person that's already a professor, they are going to have a huge interaction with you and really shape the rest of your life. So you talk to them, make sure they're a good person, okay? Make sure you can understand them well, and you're going to make some good work and not just waste 2 years of your life or whatever it is, getting a piece of paper so you can get a job. Okay, hopefully that helped. Um, Great explanation. I didn't get notification for today's live. God, really? That's annoying. I hope it sent out. I hope it sent out notifications. I'll have to look into that if it didn't, or maybe it's just a bug. Could you guys fill the chat if you did get a notification from YouTube, like pop up in your phone and says at the top like I'm live or whatever? Can you let me know if it did show that for you? And if it didn't, also please tell me. YouTube bug. Okay, so you did. So I guess after reading that, that means yeah, you did. For understanding deep learning architectures, what would be your recommended path, courses, or books? I tried going through courses. Jan's course. Most of them go from basic to advanced. I feel lost halfway. Yeah, that's fine. Yeah, no, I even today after several calculus and linear algebra courses, I would get pretty lost in a deep learning book without putting considerable effort into it. The deep learning book in particular, like Bengio's book, is crazy. And if you want to learn it, then it's the right way to learn it really well. But it's not necessarily the right way to learn it to get a job rather quickly in deep learning. You can get just doing deep learning from the specialization. So make sure I have some videos, maybe search on my channel for deep learning. I talk about the specialization, the TensorFlow specialization, the advanced one. And again, I have this video where I said the machine learning pathway of certifications. I think they are very good. I think they do a very good job of taking the material, like picture this huge of like umbrella of material that they could pull from to put in a course. You could learn everything there is, but you would never do it. So they do a very good job of picking the different parts of it, putting it into videos that make sense, ordering it so that even though you don't understand all the theory underneath, you still get the idea of what they're trying to do. And that for most people is learning the math. Okay, there's a lot more math underneath all of that. But the deep learning specialization on Coursera from Andrew Ng in particular, if I was to call it out, deep learning.ai specialization, is fantastic. The TensorFlow specialization is kind of meant to follow up that directly after, and it's very good. The professors of both are very good, but Andrew Ng in particular is phenomenal. So would highly recommend. From books, there's also the really hands-on with TensorFlow and Scikit-learn, whatever it's called right now. If you can't find it, let me know. But it's like a red and white book. At least it used to be red and white um, for for hands-on TensorFlow. Okay, so it's really, really good. It's modern. It's up to date, and I would highly recommend that book in particular. The deep learning book, if you really want to understand what's going on, but yeah, you're saying you get lost halfway. You'd probably get lost halfway. It's okay. The deep learning specialization, I don't think you would get lost halfway. I think you would follow it pretty well. And if not, just take it step by step. And if there's a reason you're not understanding something, learn the priors, and then you will follow it. Hello, I have a question. If data contains .dat file, yeah. If ECG file and dataset, how to convert into CSV? One video. I don't use .dat files. I know that in RStudio that sometimes people load those in, but I'm not really sure. This is more so a question just for the internet, not really for me too much, if that's okay. Can you suggest any cloud service to train neural network? Yeah, I mean, all of them really are pretty much the same thing. I'm a personal advocate of GCP, Google Cloud Platform, versus AWS, Amazon Web Services, versus Microsoft Azure. So those are the three that every single person will say. And there's probably some others that are not from a big tech company, but those are the ones that people like. So I've had problems, and don't make this the takeaway as AWS sucks, but I've had a lot of problems with compatibility issues with doing stuff with AWS. I find that GCP is really, really good for doing that. And if you want to actually train the neural network on the cloud, again, they're all pretty much the same thing, but I find it's easiest for me using Google Cloud. But I do most of my training on my own computer. My laptop is an RTX 3060, which I saw Krish Naik actually show that he has the same laptop now. He posted that yesterday. So I do most of my training on the computer, but I understand for a lot of people you want to do it on the cloud. It's probably expensive, so I'd be careful about the investment kind of trade-off between getting your own computer and paying to do it on the cloud. I don't, if you guys know of any actually free training services on the cloud, let me know. I'm not familiar with those. But yeah, my top recommendation is GCP, AWS would be second, and Azure. Actually, maybe it's tied with Azure for second. What's my favorite resource for stats, especially for time series analysis? Yeah, so that's a reasonable question. Statistics is a huge branch of stuff. Like there's so much to learn about it, and time series analysis is one branch that is very important. There's a regression book that I really, really liked by, I think, Abraham. So that book's really good. It's like linear regression. Does a pretty good job of explaining the mathematics under it. I forget the book, but it's just called like Introduction to Statistics. The one that I read, this is kind of something that I mostly learned from school and don't know what's on the outside for like the really, really famous stuff that probably built all the courses that I learned from. But anything really famous, honestly, probably built most of the courses, like Introduction to Statistics, if that's the route that you want to go down. But it's going to be very theoretical, and make sure that you actually care about learning the statistics from that really fundamental route before you do, because stuff like deep learning, it kind of empowers, it goes over all of that stuff without needing to go down the really linear algebra calculus way of doing all of this. But there's also Introduction to Probability Models, which in a related space I would definitely recommend. Again, I forget the author. If you can, I'll do a quick search called Introduction to Probability Models, which is, who is this by? I can't find it. There's something called like Probability Models, and it's a really good book. I hope that's okay for now. Time series analysis, again, yeah, I appreciate you asking. It's really a fundamental, like, well, of course, statistics, but you go and read the books that are really, really popular in that, and I guarantee you they're good choices. Have I ever found success using ML in stocks? Yes, so I mean, it's not something that it's not a project that I've done before. I've seen how other people do it. You might use reinforcement learning or a time series analysis approach. Uh, yeah, you can definitely look into it. That there's a lot of blogs that do that. If you're doing it to actually try and make money, I would stick with the Warren Buffett strategy of thinking really hard about the few companies that are actually going to be successful in getting stocks. If you're just talking about it from a project point of view and trying to predict stocks, then there's there's a lot of blogs out there where you can look at a project and figure out what they're trying to do for sure. You're very welcome. Related question for model training. Personal laptops would require a really good GPU. Uh, Pretty good GPU, not amazing. Is Google Colab Pro worth it? Yeah, actually. So, if you're finding that sorry, yeah, actually, totally forgot that when I said training models for free. Google Colab absolutely is /Kaggle. I don't know why that slipped my mind. Yeah, Kaggle or Google Colab. So is Pro worth it? It's worth it if you can't afford a good laptop and you you like the Collab system, which I do, and Collab itself isn't good enough. Okay, so if all those things combine, like you actually like it, you've used it for model training, and it's the free version isn't good enough, then yeah, Pro would definitely be a good option for you. That's a good choice. Love your videos, saw you on LinkedIn. Thank you so much. Really appreciate that. I am building a desktop assistant. Okay, that's very ambitious. Is there any way I can change its voice to a panda's voice, for example, or any other animal's voice? This is an awesome question that I don't think I know the answer to. Change its voice. I don't really know how voice changers work. I'm sure they are using artificial intelligence now, although they've actually been decent for now. What do you mean? How do you change a voice? Like a panda is talking in English? That's interesting. I don't quite know how that would say something meaningful. Learn about mean reversion momentum for using ML for trading. Okay, I think you know more about me than that area, so I'll take your word. I know you're talking to the person that asked that question, Brian. Yeah. So how to implement machine learning models in real life to make something useful, as in deploying them with web development, how to do that. Just check my Flask video. So that takes you from uh, knowing, it even shows you how to make the machine learning model. Really, so keep in mind, a model is just a file. Like it's a mathematical concept, but in a computer, how you're going to represent a model is parameters and a way of using those parameters to make a function. So in linear regression, it's just a file that says in some weird way that you have these particular parameters, beta naught, beta 1, beta 2, and then you don't care about the inputs of that, the x values. It's just your parameters, and that's a way of saying that what your function is actually doing. So once you understand that, and it's just a file, and it'll be different depending what you're doing. Scikit-learn, TensorFlow, or just your own kind of thing that you could make from scratch. You can just put that into any sort of app. Like you can load that, and it might not be the most optimal way. Like you might be slowing down because you're not loading it properly. Don't worry too much about that. You save something to a file and you load it back. And in TensorFlow, it's very, very easy. You just do save model, and then it makes a file, load model from file, and then that's it. So putting that into a web app, that's just having a model that you're putting into a web app. It's really not that crazy. And if you want to do something like Google Cloud Platform, like making them do the model, again, it costs money, but you could absolutely set up a machine learning model on a cloud resource that's something like GCP, Azure, AWS, whatever it is. But yeah, check my Flask video on how to do that in particular. I'm not going to answer that in specific. It's just, whatever you're trying to do, the model is a model somewhere. You train a model, it's doing something. And so you put that file on the machine that you want, whether it's the cloud, whether it's, Heroku or your phone, It depends what file you need so that you can actually load it, and there's different frameworks for that, but it's just a file you put somewhere. I am from Ontario, particularly, yes. So my home is in Hamilton. That's where my parents live, and so I'm living right now in Waterloo, very close to the university itself. How can I search international jobs for machine learning? Is there any good website you would like to suggest? Yeah, so I mean, the whole topic of applying to machine learning jobs is a big idea. So international, I know I'm going to look at your name, and so international probably means most likely where I am, or other countries as well, but the ones that people really want are often in North America. So to look at those, you really need to look at company websites. So I know people make so many different sites that are like these third parties that, scrape the web for all jobs, that type of thing. I'm not going to recommend you any of those third parties. I'm going to say, look at companies and just type in, first of all, machine learning jobs. There are stuff like LinkedIn where people actually post jobs. That is 100%. I've done a lot of applying through LinkedIn itself. Very difficult, by the way. It's hard to get these, so don't be upset if you get turned down a couple times. It's probably gonna happen. Um, if you were to apply, absolutely recommend. And so LinkedIn, even the more popular, or actually LinkedIn's probably the most popular job thing there, but there's also the other ones. I'm forgetting the name, but I'm sure you guys could type in the chat the popular job search platforms where they actually post jobs on them. Indeed is one of them. Glassdoor, I believe. So you could check those sites where people are actually posting stuff. But in terms of the third party where people are scraping, then I wouldn't really do that. There's a lot of jobs that are on company websites and nothing else. So you really do have to just pull up a list of companies, and if you're going to sort it by something like how much money you're going to maximize, whatever sort of sorting you want to do that, just go to the LinkedIn or whatever. You'll see a bunch of companies, and then go to the site and go to the jobs. It's that simple. It's also that difficult as in not complex, but time consuming. It Applying takes frickin' forever, and there's no way around it. You can't build a bot that applies to all jobs well, or any of that. You just need to go to company websites, apply well, make sure that you tune your resume to that job. Yes, it's as important as people always say. Tune your resume if you want to likely get a hit. You have to think about how long it's actually taking you to tune stuff. If you really don't want to and you're just throwing stuff out, like it's fine. But that's my answer for, in general, job searching for international jobs. Yeah. Um. Okay. So, is it possible to build an app which is based on machine learning, can give a person practical real life solution to a problem of a user after analyzing? Oh, I think I know what you're trying to say. So are you trying to say, can you make a machine learning model that answers someone's question, basically? So like you have a problem. I've actually thought about this, I think is what you're saying. At least that's why I'm thinking it. Can you make a machine learning model where someone's in a pickle, they're trying to figure out like an answer to something, just what to do, and you're going to input stuff about, like, should I get lunch today? Or like, should I get lunch at this restaurant today? What should I do in general? There's a lot of specific things you could do to make that type of model, but this goes back to like the whole fundamental problem of our machine learning stuff is it's still like 99% of it is all particular inputs fed to particular outputs. So you can make a model that does something. You could make a model that, you go to lunch or whatever at this particular restaurant because you decided you wanted sushi today or whatever it is. You could make a model like that. But to do something like that's kind of all encompassing in terms of problem solving, AI has a big problem with that. Can I make a video like roadmap to becoming a data scientist? Yes, you can look at my video on, so data scientist, I'm going to consider somewhat analysis with machine learning. So again, check out my video I just posted on machine learning certification roadmap. I do have the stuff about learning data science and machine learning way back. I have a playlist of that, I believe, somewhere. Search roadmap on my channel, and that should come up. Most of the technical jobs are posted on LinkedIn. Indeed is garbage for machine learning jobs. I probably agree with that, to be honest. I think LinkedIn is a lot better. I wouldn't. Garbage is a little bit strong, but I probably agree. Hey, have you looked into quantum machine learning? No, it's outside my thing. I remember talking about it years ago about this is where the space I wanted to head myself into, and I never did. No, talking to the wrong person if you want to talk about quantum machine learning. It's a lot. It's very difficult stuff that I genuinely don't understand. Is it possible that we can work with me on projects just to learn from me? I would really would recommend you to create a Discord server which we can join and grow. Um, Interesting. So that's why a Discord server was mentioned yesterday. Um, so I was wondering about this kind of thing because it's I don't want to waste anyone's time by going through a lot of errors. And also, me in particular, I don't really do like I could do basic projects, but I'm not going to build anything for a while that's going to be something that'll be interesting for your resume. So I'm not like I do have that on my GitHub. If you want to look at Know Your Fruit, that's on my GitHub, go ahead. That's something that you should be able to do given a lot of time. And I will never, I'm not going to say never, but it'll be difficult for me to find time to work on that with you. Although I appreciate that this is a good idea. It's just a lot of effort that I do not have time for because of who I am with school, with soon to be job, and doing YouTube constantly. It's a cool idea, and maybe I will do a live every now and then about making a project, and you can see that, like, I'm not an amazing developer either. Not to say I'm a bad developer. I mean, I can't just picture lines of code in front of me exactly what to do and get no errors. So you could definitely see that process with me, and including the design insight. I might live that, but uh, I could make a Discord server for you guys for sure, and I will drop in and kind of give my advice. So I think this is actually a good idea. Second time it was mentioned. I really appreciate the feedback and the suggestions. So Discord server for everyone to join so that you guys can work on problems together is a really good idea. Uh, I'll have to look into kind of not say legality, but just to kind of how that would work out because I don't want to make anyone uncomfortable by you're going in a server with people you don't know and I'm not there. But I think it's a really good idea in theory for sure, and it's kind of the same idea. I was thinking about making like a Facebook group or whatever. Yeah, Discord might be a good way to do that. So thank you, I appreciate it. Can you explain the concept of gradient descent? Absolutely. I hope more people join this because this is really important, and I might even just turn this into a video after. Gradient descent is the idea of so neural networks have a bunch of parameters. That's just like actually, I won't go down the neural network route. Linear regression is the easiest way to explain this by far. So with linear regression, we have beta naught, which is a parameter, which means we can tune it, we can change it. That's what we're trying to do, is to find these values, but I'll say why shortly. We're trying to find beta naught, say beta 1, x1. Beta 1 is the parameter, x1 is the associated input. And I'll just stick with that simple linear regression for now. Beta naught plus beta 1, x1 is your prediction for whatever betas you have. Okay, you have beta naught and beta 1, and they're just numbers. Okay, you can tune them however you want. We want to tune them according to some loss metric. So say we had a bunch of inputs, and so if your inputs are just x1 for the first person, x2 for the second person, whatever, you're trying to predict something, and so you have inputs to do that. You can get some prediction by your line. So you can say beta naught plus beta 1 x, the first one, beta naught plus beta 1 x for the second one. These are all a bunch of predictions. And so you'd think about some loss function where actually in supervised learning, you have an actual known answer. you're making a prediction on what you're trying to predict, but you're also given a true value of whatever it is. So this is supervised learning. And so you can think about a loss function. We're introducing this idea of how good or bad your model is. So we want to know how good or bad the model is. And to do that, you would think about the error of getting your predictions uh, on compared to the actuals. Okay, so you'd get a prediction from the input and an actual prediction and an actual. And so you could quantify the difference between these two things, just get the difference of them, like literal subtraction. Maybe take the absolute value or square it. Most commonly we square it. And then if you sum up all of these errors between actual and predicted, you square those differences and then you sum them, you get a number and you get a positive number. So from that, this is a known function. Like that function is just some way of describing the error. And so you can get the derivatives with respect to beta naught and beta 1, or whatever your parameters are. Same thing if it's a neural network, but beta naught and beta 1, you can get the derivatives of the error with respect to beta naught and beta 1. And if you're doing straight up regression, what you can do is just set these derivatives, which are functions, by the way. You can set them equal to 0, and then you can solve, and you would get, something like, if you were doing multiple linear regression, the formula, which I just wrote down today from my course, is x transpose x inverse x transpose y, but that confused everybody. And it's just a way of saying you can solve for beta naught and beta 1 that minimize that error. And that's not what gradient descent is, okay? That is solving it exactly, which most of the time we don't do. Gradient descent says instead, okay, I'm still going to get those derivatives, except instead of just solving this thing exactly, and it's a weird conversation as to why you can't do that. The main reason is, technically, if you want to look it up, we have to use gradient descent because our functions are not convex, which means kind of bowl-shaped, like you can get an absolute minimum. But you can still get the derivatives. And then so wherever it is, this is kind of tricky without drawing it, and I'm not going to draw it right now. But the point of gradient descent is to say, okay, if I calculate the gradient, which is just a vector of derivatives, the gradient for beta naught and beta 1 is just the derivative of beta naught and derivative of beta 1, or the derivative of the loss with respect to beta naught and the derivative of the loss with respect to beta 1. Those things, you calculate this value, and whether it's negative or positive, then you move a little bit in the direction of the derivative, okay? And actually kind of the opposite direction. It's a little bit weird. You can look up the math as to why. But the point is that we kind of iteratively move along based off of the derivative. And since our derivative is a line, I'm drawing on something that's cropped out, the derivative is a line. So we approximate the function with a line, and then we move a little bit downwards. And if we keep moving a little bit downwards, depending on what our derivatives are telling us to do, that's how we know how to move down, is to look at the derivative. Move it a little bit, and that is going to get us a local optimum. So I would need more to explain that, and follow my course for machine learning, and I will get there, believe me. But that's the idea, is we just iteratively keep calculating the derivatives. We know the derivatives is a function of the loss function, and we're just moving down the loss function. That's all that machine learning or supervised learning ever is. So very welcome. I'm gonna make a video about how to use big data in machine learning. I mean, yes, big data it usually implies Spark nowadays, and so that means a lot of values in parallel. Really, all the video would do is show that you have data. That's a lot of it. You would use Spark to transform it into like a table format, and then convert that into NumPy, and then do machine learning. Or there's some kind of Spark stuff itself that you can do, but most of the time you're going to translate it to NumPy and do TensorFlow. I am very glad you appreciate it. Yes, you're very welcome. Please suggest which is better, Seaborn. Honestly, I don't know Seaborn, quite genuinely. I know that it's like everyone learns Seaborn. I like Plotly actually a lot more. I've seen what Seaborn does, and it's fine. There's nothing wrong with it. Matplotlib is great for really basic stuff, which is nice because it's just you write 1 or 2 lines and it's like it does what you want it to. But so does Plotly. So I would highly recommend looking into Plotly because it's not much more difficult, if any. Might even be easier. And it does so many more cool things. So look into Plotly for sure. Is Kaggle a good place to start machine learning? I know Python and I have done a little bit of work with NumPy and Pandas. How would you have done it? Thank you so much. You're very welcome after I give my answer, which is so Kaggle. So I had this a little bit of discussion earlier, which was Kaggle is, you know, good for practicing machine learning. And it's a good way if you want to kind of purposely get stumped. And so you look at Kaggle and you get stumped right away and you have to follow someone's blog. There's a lot of blogs for solving these things, which are great. There's a lot of material there. It might be a little bit, if I use the word depressing, that, you kind of go on Kaggle and you're just stumped like over and over again. And if you enjoy that and getting stumped and learning and getting stumped and learning, you're going to learn a lot. But for actually starting learning machine learning, it's probably not my recommendation. I'd follow my machine learning course if you can, and if you're ahead of that, then feel free to like learn other resources. Andrew Ng's machine learning is great as well. Again, check out my certification video for, I say, follow machine learning certifications pathway. I recommend doing IBM Data Science, which I think the IBM Data Science is in the description of this live right now. As well as, you progress towards machine learning, deep learning, and then focusing later on. You're very welcome. So I didn't quite answer that. You have a little bit of work with NumPy and Pandas. How would I have done it? So yeah, I mean, actually, I did answer it. Sorry. So that's what I would do is machine learning from Andrew Ng's, how I learned a lot of it. You know, I would recommend now getting the certification as well, just because you're putting in all of the work anyway. Especially check out Coursera Plus, because if you're going through a lot of this material, it's really helpful. It's just cheaper that way if you're getting a bunch of certifications, so check that out. But again, you don't have to do the certification. Go ahead and just audit the material if you want to. Yep. How do you approach non-linear dynamic datasets? Say if the variables are random. Unless this is ridiculously advanced, I don't quite get the question, because I mean, data isn't random. You can think about a random variable as in, it's not decided what it is yet. It follows this distribution, and then it turns out to be this value. But data itself, is not random. It is data. It is numbers. So I don't quite get what you mean by that. Also, we're out of questions here, so I'm gonna go until 4:30 my time, which is 17 minutes from now. So please ask me some questions until then. And I really need to get a drink, but I'll wait 17 minutes. That's okay. You're very welcome. Very welcome. Cool. Anything else? Anything else, everybody? I could stop early if that's it, but I'd like to keep going if you got anything. Come on, everybody. Ask some questions. Say a variable, that is what I thought you were talking about. So say a variable follows a geometric distribution. Well, so a variable, sure, we'll have the statistics topic shortly, or a quick one, is, yeah, you have random variables, which is not data. Like unless I'm missing something here. Random variables is a mathematical concept of uncertainty. It's saying this is random and not necessarily uniform random, as you said, say a geometric random variable. Brownian, sorry, I don't know Brownian motion. This might be more advanced statistically than I know. Yeah, okay. I'm just gonna, sorry. Now that you've said that, I'm gonna realize I don't think that I'm fit for this question. Sorry about that. Greg, will you make deep learning videos? Yeah. So I mean, I have a tutorial on TensorFlow, which does not TensorFlow itself, but using TensorFlow to make an image classifier, which is a great introduction for deep learning for sure. So I'd recommend checking that out. I would also consider. Sorry, I was just looking at the chat there. So for deep learning, I am going to focus on making that at the end of my machine learning course. Okay, so and actually not really the end. It's I'm going to jump into it for my ML course that I release a video every day. The whole point of this course is to get to deep learning as quickly as possible, but I'm definitely starting with a firm understanding in simple linear regression. Might even do a little bit of logistic regression. I probably will, just from a machine learning point of view and not really a statistics point of view, and to ramp up into deep learning as quickly as possible because that is where everything is at. That's what you should be doing. It's just there's a lot of stuff you should be doing before deep learning. Okay. I straight up don't know PyTorch. Like I just, I do so many things throughout the day that it's tough for me to keep up with which is better, this or that. And so you guys, I absolutely understand asking the question, which is better. I'm gonna assume that TensorFlow is better, but I can't say. It's actually on my to-do list is to learn PyTorch as well. I've seen the syntax a little bit and it looks relatively similar, but I think TensorFlow is good. I will say that I think PyTorch is better for object detection and kind of computer vision type stuff as well. Um, but TensorFlow still has all of that. It's so well maintained. And yes, of course, there's a lot of bugs if you keep up with the state of the art of it. But TensorFlow is extremely mature and it's very widely used. So I would recommend learning TensorFlow for sure. But I'm sure PyTorch is very, very good. Although I straight up do not know it, I'll be honest. Um, is machine learning in machine learning, can you add, can I explain the concept of a random walk? This is really, you must be taking statistics right now, no? Um, random, sorry, I'll get to, that question is interesting. Random walk is basically just, um, read about probability models. I don't want to talk right now about what a random walk is. It's just kind of moving randomly, like a step forward or a step back based off of some probability, and it turns out to be very useful in a lot of different things. That's the very, very basic version. You can also, it also helps to apply that random walk idea to like even stuff like what's it called, like Google search engine. It has a lot of based, sorry, I'm stumbling. It has a lot more than what I just said, but I'm not going to explain that concept here because it's very complex. In machine learning, can you add more detailed videos on data pre-processing? I absolutely agree, like 100% agree. It's such a undervalued topic of just encoding variables and processing them to get it right. And the reason that people don't really, it's a less common video is because it's in there, like in every tutorial on machine learning and deep learning, like it's in there as a step. Um, Pre-processing, you can talk about the idea of pre-processing for sure in different scenarios, like doing turning stuff into one hot vectors and categorical stuff, or standardization, like converting it to values between -3 and 3, or like dividing by the maximum to get values between like 0 and 1 or something like that. um, it's it's just hard to make a video on that that's going to encompass, be very applicable to many different scenarios well, because it's feature engineering like this is such a topic that depending on the problem, you're going to do toy with it a lot. But you're right, actually. Thank you. I should make a video on something titled pre-processing in there to just talk about those ideas. I guarantee you it'll be in my machine learning course eventually, and that's what I'm making the focus on for sure. Yeah, you're right though. You're very welcome. Yes, I am very passionate about it. Next time if you're around Peterborough or the GTA, give it interesting. Okay. Um, I mean, I'm going to Toronto actually this weekend, next weekend. That's interesting. Cool. Thank you. You're very, very welcome. Okay. I think I'm gonna call it there. I'm gonna wait a couple seconds if someone else asks a question, and I'll give that. But yeah, really, really appreciate everybody coming again. Very popular. It means a lot to me. And I'm sorry I couldn't answer the question about like a random walk or whatever. I could. It's just a very statistical question. Okay. I'm gonna assume that's it. Then I will say again, thank you so much. Really, really appreciate it. I'm gonna log off now. I'll see you next time. 100%. Bye bye. Do I know the concept of up dog? What's up, dog? There you go. I made you happy.